All right, let's just do this. R, what's R?
Root 54.
Root what E4?
54?
50?
No,
How about root 34?
Yeah.
Which it is, and let's just see. That squared plus that squared equals that squared. So that's 25 plus 9. Take the square root. That's root 34. Okay. And so since that's the case, I'm going to go ahead and write that up here. Space. Let's just do it like this. We know what that is. Notice I call it R, right? This should be suggestive of something that we're going to talk about, or that we have talked about.
Radius?
Like a radius. Think about it as a radius, right? The hypotenuse, we usually we'll think of as R. Okay, so what's sine phi?
5 over root 34.
5 over, right, because it's opposite over that. 5 over root 34. What about cosine?
3 over root 34.
3 over root 34. Finally, tangent is
5 over 33.
Yeah, 5 over 3, because that's opposite over that. Now, let's see, is there anything I wanted to say before that? Okay. Now, you see how I set this up, right? I just gave you a triangle. Another way I could have done this was I could have said, think about the point, and I'm just going to do, this is how your book does it. It does capital P, and then it gives you a coordinates. And anytime you see that capital P, it means the point. And I could have said the point, -3, 5. And what you could have done is said, okay, well, where is that point? And you do something like this, and you'd say, well, you go over to -3, you go up to 5, and there's the point. And what your book is going to do is say that it's the, how does it, I want to see how it says it exactly. It's going to say, find the values of the trigonometric functions of theta if theta is in standard position and P is a point on the terminal side. So by standard position, they just mean that we're starting here on the positive x-axis and we're measuring counterclockwise, right? And so what I could have done right here is said, well, here's this point, measure from the standard position, and what they mean then is like that there's a line or whatever that connects this guy to the origin, right? If you draw a line from the point to the origin, then this right here would be theta. You'll notice, the way I've done this, theta is not the same thing as phi, right?
Yeah.
Now, what we're not going to do today, we will go into the unit circle in a second, or next time during our next class. And a way that we could think about this right now is, you'll notice we could take this thing and think about it as being on the unit circle if we shrink that triangle. In other words, if I take my radius, r, and shrink it down to 1, then what would the other sides be? What would this side be? Sine. Just actual, if I shrank this down so that this length became root 30, it goes from root 34 down to 1, what would I have to do to this number to shrink it down accordingly?
It'd be 5 over root 34.
It'd be 5 over root 34. 5 over root 34. This length would be what?
3.
Right? And this is the principle that we talked about like on day 1, that if you take a right triangle, and this is indeed a right triangle, sorry, you could scale it by a constant factor. Our constant factor was 1 over root 34, and we multiply every side by that, shrinks it down. Another cool thing is that since the radius is 1, you end up with a point on the unit circle. And we briefly talked about this, and we'll talk about it again, that the point here, xy, is actually given by cosine theta, comma, sine theta.
Yeah.
Right? That's how we said we will. We haven't officially done this yet, but that's how we said we will extend this. That when we eventually, if that's theta right there, that angle that's swept out right there, When we go to extend sine, cosine, and all those guys to be actual, to take on values
So cosine
of theta that are bigger, that are not acute, right? This is how we're going to do it. We're going to take the cosine value to be whatever the x value is on the unit circle. And in this case, it's not positive 3 over root 34. What is it? It's negative, right? Because it's on that side right there. In fact, that x value right there, the x value is negative 3 over root 34. Is this positive or negative?
Positive.
The y value is positive because he's above the x-axis. And so this y value is that. And indeed, that's what this means. That means that cosine theta is equal to negative 3 over root 34. This is how we're going to eventually formalize this. Ditto with sine. Sine theta. When you're talking about the angle that's swept out, measured from the standard position, measured from the positive x-axis to whatever that terminal point is. Now you'll notice that what we're setting up here is exactly the same thing. It's just we haven't shrunk this guy down. Okay, but this is the way your book chooses to do it. It doesn't introduce the unit circle. It introduces this first and then goes into the unit circle. I kind of like that. I kind of don't, but you know, I want you to see this before to see where we're going. But this is how your book is going to jump from this guy into this here. Now, this is the thing, right? Now this is what your book does. So let's see, there's other things I wanted to say. Okay, you'd be able to construct a triangle. And cool thing is here, if you haven't, one thing I like about this method here is that if you have it in your head, this right here, this might get a little tricky in thinking about, okay, well, we're on the unit circle, and now if I want to measure that, we're not on the unit circle, and so I have to stretch it, blah, 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 blah. But what I really like here is that by this point, it should be drilled into your head, where that if you're given any triangle, and any right triangle, in any orientation, you should be able to find, okay, opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. You'll notice I didn't bother with cosecant, secant, and cotangent because it's just the reciprocals, right? But since that's the case, since you've already drilled this into your head, we're going to use that and say, well, again, right, with a thought in mind to the future, what I'm going to be doing is thinking about this on a unit circle, blah, 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 blah. What you could do is say, well, since really, ultimately, all I'm trying to do is find the height here, and that height is sine. All I'm trying to do is find the base here, and that base is cosine. I could treat this like how we had before, this phi right here. I could just kind of forget the larger context and just say, well, the same kind of stuff we did before. We know if this is 3, and if this is 5, then this must be root 34. And then we could just, but now instead of using this, and I'm going to go ahead and introduce this. I wasn't going to introduce this before. This has a special name. And we have a special symbol that we use. That is a theta with a subscript r right there. Okay, so this is what I've drawn. I've drawn this angle and then a little r. And this is called the reference angle. We'll define this a little bit better in a minute. But I'm going to go ahead and bring that in. And I might as well define it right now. So, given any point on the plane, in this case, minus 3, 5, you can construct a right triangle, right, by drawing a line directly from that point down to the x-axis. And since that's the case, it doesn't matter where it is. I'm going to go, I do want to leave that up. If you had another one somewhere, let's say it's down here, that's your point that I gave you. You could construct a right triangle by, 1, drawing a line from here to the point, from the origin to the point, that's going to be your hypotenuse. And then you draw a line directly to the x-axis. Since it's directly to the x-axis, that's a right angle. And this angle right here is what we call the reference angle. And then the actual angle measured from standard position is what we're going to call whatever it is. I happen to choose theta. I could have used alpha. I could have said alpha is the angle going from here to here, in which case I would say that the reference angle is alpha sub r, right there. So in this case, right, we know that this height is 5. We know that this base is 3. And we could think about this the same way we did before. It's already been drilled into our heads to say, well, if I need to find sine, I just go here on this triangle and go that one over that one, right? But now the only thing we need to think about is the actual values of it. So just for right now, r is always going to be positive. For right now. R will be negative soon, and I'm sorry. But for right now, the radius is positive. So really, it just comes down to, if I'm computing sine of theta, right? This is now we're going beyond this little triangle here. What we actually care about is extending our definition to include negative values and values of theta that are bigger than pi over 2 or bigger than 90 degrees. Now this is how we're going to do it. We're going to say, you take your point, you do this kind of thing, and now we're just going to use the actual values themselves. So is 5 here positive or negative?
I'm positive.
Positive, so we're going to go 5 over root 34, which is positive. What about cosine theta?
Negative 3.
Negative, right? And in the way that I do this, I normally don't have this here. I just do it that way, right? And say, well, okay, cosine's that over that. And then I just ask myself, is it a negative number? Yes, it's a negative number. It's a minus 3 over root 34. Now, what about tangent?
Negative 5. No, well, 5 over negative.
Yeah, and this is how I do it. Again, thinking about it as a reference angle. I'm not worried about actual theta for a second. I'm trying to compute tan theta, but I'm not really worried about that theta. I'm looking at the reference angle. Because I know ultimately all this comes down to is just lengths. In the same way I do with slope, remember? Like when we did this last year, I said I don't worry about the sign at first. I just say, okay, rise and run, whichever way it goes. Then I ask myself, is it going up? Then it's positive. Is it going down? Then it's negative. Same kind of thing here. I'm just going to say, well, I know that tangent is that over that, so I'm going to go 5/3. Then I'm going to ask about signs. I have a positive over a negative. Okay, so it must be negative. If it were a negative over a negative, it would be
Positive.
It would be positive, right? Now, you'll notice these things are only different by a sign. Not S-I-N-E, S-I-G-N. It's different, it's either plus or minus, right? They're plus or minus of each other. And that's a really cool thing about this, right? Because ultimately, let's keep in mind where we're trying to go. We really want to stay on the unit circle. Oh, and look at that. What did we get for cosine theta with the unit circle? Negative 3. Oh, yeah. What did we get for sine? Was it positive? Yeah. And so it's all going, this is all really the same thing, right? It's just, this is another way of formalizing all of this stuff. Okay? So again, given any point, we'll do this one more time. Now I'm going to get rid of the unit circle. Okay, so given any point on the plane, say it's right here, we can draw a line directly to the origin. That's going to be our new radius. Draw a line directly to the x-axis. That will end up being a right angle, which will let us here, well, actually, we're not going to get there yet. So then what do? Well, we define, we could say then there's some angle that goes from there to there. We're going to call it theta. And what we're going to do is this type of thing. And let's say that this point is x comma y, right here. Then that means that this length here is x, and the actual x value is here. So maybe x is like -2 or something like that, right? In this case, y would live right here, and that length would be y. And really, the way I think about this is the way I did before, is like we have the absolute values there, right? Like that's how I'm thinking. If it's -3 as it was right here, I really just think about it as 3. And then later on, I'll bring that in. But your book goes through this right here. Let me see. Just give me a second. I want to make sure I haven't skipped something I want to say. Yeah, and the reason why we're doing it this way, we're going to see this as, instead of trying to figure out the whole context and then thinking about it in terms of this, is that you've already drilled this into your head, right? And this way of thinking about, well, sine is opposite over this and blah, 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 is we could just use that right here. And we could take the reference angle, deal with the reference angle, blah, 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 and then just ask ourselves, is this a positive number or a negative number? And it works really, really well. And then it'll also, if you have this in your head as the definitions of sine, cosine, you know, the opposite over hypotenuse and all that, if you have that in your head, then when you're no longer working on a coordinate system, right? Like if your problem says, you know, Billy lives 5 blocks west and 2 blocks south of blah, 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 blah. What direction should I send my homing pigeon, blah, 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 right? To go send a message to Billy. Like, it's nice because you could, again, okay, so I guess I did put a coordinate system there. But really, this is how you're going to set it up, right? You're not going to be trying to think of, well, what is that in reference to this? Really, this is what you're thinking about here. That's a 2, that's a 5, and so this is a whatever it is, blah, blah, blah. Am I making some sense? Yeah. Is that, you see what I'm saying? Like, it's nice to actually have this locked in your head because it's so simple, right? You've already drilled it enough. And so when we go to extend this into, now we have this, it is nice to be able to, no matter where your point is, drop this, make a reference angle, think about it in terms of the reference angle, and then at the very end, add in your, whether it's positive or negative. So, okay, that's what I wanted to say about that. But now that we've done this, now that we have this nice little picture on the board, yeah, I said all that. Okay, so R, obviously, so we've been given a point X and Y. R, should be obvious, is the square root of X squared plus Y squared, right? Like that's how you would find that. That's how you found that right there, right? It's just the distance. That's how we find the distance. Since that's the case, we could, if we were so inclined, from the very first day, we could have defined sine to be simply y over r. Like, and I mean the actual coordinate. So if that's a -2, you would put -2 right there over r, right? Ditto with cosine. Only cosine's going to be what over what?
X over R.
X over r, right. So that makes tangent equal to what?
Y over X.
Yeah, y over x, right? So that opposite, and again, right, I'm not thinking about that theta, I'm thinking about that one. I would go opposite, which that length is y, over adjacent, and that length is x, and so y over x. And ditto for all the other guys, right? The thing is, but this is going to be 6 new things to remember. Like, this, we could have started this way, and we could introduce this now, but I think it's much easier, really, to think about this in terms of reference angles, right? Like, you have some point on the plane. All we really care about is these ratios of sides to each other. Now all we're going to do is add in the pluses or the minuses, right? Is that making sense, what I'm trying to say here? Yeah. Okay, so, okay, let's do an example. So, part of your homework. So, in fact, like all of this right here, this is what you're going to be doing with these types of problems, but I'm going to suggest you don't even bother with that. Like, I didn't bother to write everything out. I would say just use what you know already, and then use your brain a little bit to figure out whether it's positive or negative, right? So here we go, number 72. So this is, yeah, we're starting, your homework starts with number 71, this is number 72. Oh, and this is, oh, I did write on. Okay. It says the same thing that we were just doing. The point is at minus 8 comma minus 15. Minus 8 minus 15. And it says, I'm just going to go ahead and read it out. Find the exact values of the 6 trigonometric functions of theta if theta is in standard position and P is a point on the terminal side. I said that earlier, but just so that we're all clear, that as you measure an angle, you're starting here, so that's the initial side, and the terminal side is where it ends, where it terminates, right? So, nitnoid stuff, but that's the idea. So if theta is the angle on the terminal side, means we have minus 8 minus 15. So that means we're over here at, actually I'm going to bring this back a little bit, make it look a little bit nicer. That's minus 8. And we'll make minus 15 right there. Everybody buy that? That's where that point lives. And so that's on the terminal side. And so this guy flips around and goes there. Okay, and so this is theta. This is what the book is saying with these questions right here. Now, what it wants us to do is find, and I'm going to go ahead and write all these out, and then we'll actually do them. We want sine theta, cosine theta, tan theta. We want cosecant theta, secant theta, and cotan theta. Okay, so first thing I'm going to do is I actually want to construct my triangle. Yes, I believe that you're smart enough to just be able to go, well, that's that over that, and blah, blah, blah. I don't trust myself. I have to see it. I suggest that you do this too, right? And we could think about, okay, now this is the triangle we care about. This is my reference angle right there. I'm not going to bother writing it in there, but that's the part I'm looking at. And now I'm going to forget about all this other stuff. And I'm going to say, this length from here to here is what?
Minus 15.
Yeah, but just the length itself is 15. Oh. But yeah, you're right. And what's this length right here?
8. Negative. Well, we add that length.
Right, yeah. Just, that's how I do it. What's that length?
15 squared plus 8 squared root.
And we take the square root of 15 squared plus 8 squared, which happens to be 17. We don't need to worry about that. I believe that you could figure that out on your own. It turns out to be 17. Okay, so if that's the case, now, what is sine theta?
15 over 7.
Is it positive
Oh,
or
negative.
Oh, negative 15.
Yeah, okay. Because again, remember, sine corresponds to the height, right? Because like we've seen that on the unit circle, that sine are the y values, right? If we were to shrink this onto the unit circle, then sine would just be that height right there. Now, of course, we haven't shrunk it, right? And so we haven't done that thing where we divide through by the radius to make that guy equal to 1, but it would be... So once again, what is it? Sine theta is?
Minus 15 over 7.
Wait, but would 17 be negative?
No. Like I said, we're always, for right now, the radius is always going to be positive.
Alright. Yeah.
And yeah, it's down there, but the thing to remember is, really, this is just kind of like a mnemonic. Like, everything that or a heuristic. Maybe it's a heuristic. Like, what we're doing right now, it's not like this is I don't like this definition of it. I like the definition that sine is simply, if you're on the unit circle, it's your y value. And so in order to make all of that work together, we have to require that that's a positive number. Otherwise, we can't really apply that here.
Well, we found it by taking a square root.
And that's another good point, right? How did you find it? Well, you treated it as a positive distance, and so you took a positive square root. So, okay, what's cosine?
Negative 8 over 7.
Negative.
Negative 8 over 17. The way I would do this is I would look here and say, okay, cosine is adjacent over hypotenuse, so 8 over 17. Then I ask myself, is the x value negative? Yes, it is. And so, negative. What about tangent?
Be positive.
Yeah, positive.
Positive what?
15 over 8.
15 over 8. So that makes cotangent what?
8 over 15.
Are you sure it's still positive?
Yes.
Yeah, right. What about this guy?
Negative
17
17
over
over 8.
Are you sure it's still negative?
Yeah.
Yep. Okay, what about this guy?
Negative 17 over
17 over 15.
There we go. Okay, so that's what we do. Please, as you do these, I put this in the comments and the homework, write all of these out for right now, because this is part of you. As you're learning this stuff, don't just write these values individually. I know that's how it is in the back of your book.
Yeah.
But right now, I want you to see this, that this is what sine means in this context. This is what cosine means in this context.
It was kind of confusing in the back of the book because I didn't know which order.
Yeah, and so same here, and I think I wrote that on your stuff. I was like, I was also confused about this. It's like the back of the book does sine, cosine, tangent, cotangent, and then one of these whatever. I mean, whatever, you know. If you got these, if you got the first 3 right, you probably got the second 3 right too. So, okay, everybody got that? So there's a bunch of questions like this. They give you this weird, like, this data is measured from the positive, or measured in the standard position. This is what they mean. Put the dot, draw the lines, and then that's what we're looking for. Okay? Questions before we move to the next type of thing? So, since we're talking about stuff in the plane, and now we're starting to bring in coordinates, it's going to be useful to name the different quadrants of the plane. Quadrant meaning 4, right? There's 4 places on the plane. We number them starting here, right? And so the same way we measure angles, we're starting here and moving out this way. And so the first one is here. We call it quadrant 1. And we're going to use a big, I was about to say capital I. That's a Roman, thank you. The Roman numeral 1. And so now we go to here, and can you guess what this is going to be?
2.
2, Roman numeral.
Roman numeral? And you'd be wrong. It's actually Arabic 2. No, yes, it's the Roman numeral 2. What about this one?
3.
And this one? Yes. Okay, so those are the 4 quadrants. If you get them confused, just remember how we measure angles. 1, 2, 3, 4. Okay. So, the next type of question says, find the values of the 6 trigonometric functions of theta if theta is in standard position. Okay, so again, we're measuring from here, right? And, this is some of my favorite stuff. And, at least in this section, this is probably my favorite type of question. And the terminal side is specified. And what they're going to do is actually give you a line. And so, this is what the beginning of those say. And then it'll give you a number. And it'll, for instance, 76 says, so that's, I didn't say anything about the quadrants. It's in this, that's what it says, is in the specified quadrant and satisfies the following. Okay, so it's in the specified quadrant. It's in quadrant 4. Okay, so in other words, we're thinking, immediately I'm thinking, so there's like some line sticking out here in quadrant 4, and we're measuring all the way around like that. Okay? And it's on the line. 3y plus 5x equals 0.
So, Y.
What?
Well, we need to solve the equation.
Y equals
Maybe-
negative 5/3.
My intuition tells me let's just graph this, right? And maybe it'll make some more sense if I graph it. Because honestly, when I first saw these, I was like, just what? Wait a minute. What are they talking? What are they even talking about? So let's graph this line. And you told me that y equals what?
Negative
Negative 5/3 x.
Equals minus 5x, and so y equals minus 5 over 3x. Okay, so again, just like last year, like let's just, like, does this line go up or down?
No.
Where does it go?
Fourth quadrant.
It goes through the,
Zero.
what? It goes through 0, 0,
Yeah.
right? I mean, there's no b here, and so I know that it does this. And for this one, of course, yes, it extends back that way, but we don't care about that right now, right? For this problem, or for these problems, always assume that they go through the origin. Okay, like they could be a little ambiguous the way they're worded. Assume they go through the origin. It'll give you a line and it'll be shifted up. It'll say like parallel to, but then it won't tell you any more information. You're like, well, there's infinitely many parallel lines to this. Just assume that the one they're talking about goes through the origin. Okay, so it looks like that. What do you want to do? How are we going to find? What should we do?
Well,
Well, we need to plot negative 5 and 3, so we can see the
Okay.
sides of the triangle and find the hypotenuse.
So you're telling me we need a triangle?
Yeah.
Okay, right. So ultimately, if we do something like this, right, that's our goal. If we could get this triangle right here, and we could think about a reference angle there, then the thing that they care about, this guy right here, theta, we'll be able to find sine theta, cosine theta, tan theta, and I'm only going to do these three, because if you got these three, you should be able to get the other three, right? So, okay, well, how do I deal with this? How can I find these two lengths?
Let's rise over around. So,
I like that.
so negative 5/3 or 3 or 5
Which
over
one's,
negative
so which one's the rise and which one's the run here? In terms of this
Rise
triangle,
or rise.
is this the run or the rise?
rise.
That's the
And
rise.
5 is the rise.
And the 5 should be the
Oh,
rise.
okay, so negative. Oh, wait. But
And then 3.
And then 3 would be the run.
positive.
There we go.
Okay.
Here's another way we could have done it. Okay, I have a function. I could plug any number in here and find an output. We know it goes through one of these. So it's like, I could have, if I were so inclined, say, well, this thing does this. I could plug in, I don't know, how about a 6 if I were so inclined? I could, and I could say y equals negative 5/3 and then plug in a 6, which would give me negative 5. 3 goes into the 6 2 times, so that leaves me a 2, which leaves me a negative 10. And so my output would be down here at negative 10, making this 10, and making this 6. Is that the same triangle?
Yeah.
So like, it's easy, and with this problem, you might think, oh, I need to be able to just do it with the rise and the run. You can. In this case, it's no problem. Maybe you have a more difficult one where it's not so easy to see that. I think in every case it should be easy to just use the rise and the run. But in case it weren't, another thing you could do is say, wait, that's a function. I could plug in any number, get out another number, and then I'll have a point that's actually on the thing. I'm good to go. Okay, so what else do we need in order to...
Hypotenuse.
The hypotenuse, which is what?
Oh, it's the same.
5 squared. Oh,
Root 34.
Yeah, right? Right, we did this earlier. This was the first thing that we did, right? 5 squares 25, just to make sure. 5 squares 25, add 9 to that. It's not quite 35, it's one less. 34, root 34, there we go. So, sine theta is what?
5/34.
Negative.
Aha! So this is the way I thought about it. When you said that, I go, yes, it is 5/√34. Now stop and ask yourself, is that length that you just used, is that leg a positive or a negative number?
Negative.
It's negative because it's down there. Another way of thinking about it is, if you're talking about sine, if your point is in the top 2 quadrants, sine is, well, positive, right? Because sine is the height, right? And the way that we're setting these triangles up, that's always the case. Sine is always your height. Your width is always with x. And so if you're over here, your x's are always positive, so your cosines should always be positive. So you know. So on that note, what's cosine?
3 over 3. Positive.
And it is positive because the cosine corresponds to the x, or you could just look right there and say, yes, that's a positive 3. And so there's that. What about tangent?
Negative 5 over 3. Yeah.
Over positive 3, right? This 5 is down here, so it's negative, positive, negative. And then the others are just the reciprocals of those. The signs should, the pluses or minuses, should be the same. Okay? Any questions on that kind of question? It's just, this is what they do with every one of these. It gives you a line, and you do this. All right. Let's look at in the video. There's a really bad glare right here, or somewhere right around here, and it's like I'm trying to avoid that place as I write stuff. Okay, here we go. So, I'm gonna put this back up. 1, 2, 3. I'm not sure if, what did I say earlier? The Arabic was, now I have a hard time remembering.
I think you wrote it like the first one.
I can't remember which way it goes for Arabic. Oh well. Okay, because it goes one way or the other. Like this is 1, and 2 is either like this or it's like that. I think it's like that. And then 3 is 2 of them. And then 4 is like the other way. And then 5 I think is like that. 6, I don't remember. Oh well. Used to know a little bit of Arabic. Okay. That's neither here nor there. So, number 84. These are cool. So these say find the quadrant. So the answer is either Roman numeral 1, 2, 3, or 4. Find the quadrant containing theta. So again, we're imagining you're measuring some value theta, and okay, there's that. Like if you're measured that far, then theta would be in the second quadrant. That's what they mean by this. Find the quadrant containing theta if. And then the different questions have different bits. I'm going to do 2 from 84. 84a says if tan theta is negative and cosine theta is positive. One of these is easier to deal with than the other.
Yeah.
And I think it's easier to tell where so first off, where is cosine positive?
The bottom. Wait.
Cosine corresponds to either the x or the y. Which one is it?
The x. So in the right to it.
It's on the right. It's in. So if cosine is positive, that implies that it's either 1 or 4. Did everybody get that? Right? Because the way I like to think about it, this section of the book is doing it a little bit differently. It gave you these silly definitions, stuff like that, right? Since r is always positive, then if x is positive, cosine's positive. If x is negative, cosine's negative. I like to think about it as on the unit circle, the x value on the unit circle is the value of cosine. The y value on the unit circle is the value of sine. But they're both equivalent, right? They both mean the same thing here. So, we're either in 1 or 4. So now, given that we're either in 1 or 4, where is tangent negative? Can tangent be negative in the first quadrant?
No. Nothing could be negative.
No, good observation. Nothing's negative in the first quadrant, right? In fact, all of these guys are positive in the first quadrant. So that leaves us with
Third quadrant it would be positive.
It could be positive in the third quadrant, because think about it this way, right? This is how I like to think about it. If you think about the reference angle, you're taking, and since tangent is opposite over adjacent, this is your opposite, that's your adjacent, that's a negative number, that's a negative number, negative over negative is positive, and so it must be in which quadrant?
2, right. 2. Because it's...
That's not a possibility. We're either in 1 or 4, because cosine has to be positive.
Oh, it can't be 3. So it could be 2 or 1 or 4.
Wait a second. Wait a second. Both of these have to be true. We already figured out that this implies that we're either in quadrant 1 or 4. This is what this means. So right now, we're working in these two. These are our two possibilities. Now we just have to figure out in which one of these is tangent negative.
4.
No, 4.
1 would be all positive.
1 would be all positive, so then that wouldn't happen, and so it must be down here. What you could do, now that that's your guess, my guess is that it's in 4. I'm pretty sure that's my answer. Let's just check it. Let's put something in quadrant 4 and say, okay, there's your angle theta. Now let's just see. Is cosine positive?
Yeah.
Yeah, because you would go adjacent, which would be a positive number, over your hypotenuse. So, yeah, okay. Now what about tangent? Tangent would be this number. Is that positive or negative?
Negative.
Over a positive. Negative over a positive is a...
Negative.
Is that... Yeah, okay, so we're good. Quadrant 4. Okay. Same type of question. Still number 84, letter C. It says, find the quadrant containing theta if cosecant theta is positive and cotangent theta is negative. So again, one of these is easier to figure out than the others.
Well, if cosecant is positive, then sine has to be.
There you go. There you go. So there you go. This means that sine must be positive. Do you both buy that?
Yeah.
Right? Because this is just 1 over sine. Right? By definition, that's just 1 over sine. 1 is positive. Like you haven't changed the plus or the minus. You haven't changed whether it's plus or minus. You haven't changed signs, right? When you go from here to here. And so they have to have the same either plus or minus, right? So that's this. So where does this occur? Which quadrants does that occur? What?
1
Uh-huh.
and 2. The ones above.
Yeah, because I really want you to start getting in your head. Sine is height. Sine is up and down, okay? Cosine is right and left. Think about, like, we will come back to this, and we will do this in greater detail. But really, next week, we're going to use the unit circle definitions of sine and cosine, which is just a coordinate on the unit circle. And so, if the sine is the y value, the up or the down, well then, if sine's positive, it has to be up here, and there's only 2 possibilities there. Okay, now, cotan is negative. Which of these quadrants makes cotan negative?
4. No. 2.
It's going to have to be 2. And you can use process of elimination by saying, well, I know that everybody's positive in the first quadrant, right? So it has to be 2. Or you could also say, well, hold up, cotan is instead of, and we could think about it, so there's 2 possibilities here. Either this is your thing, or this is your thing. You're measuring all the way there in either case. In this case, cotan would be adjacent over opposite, and so you'd have a positive over a positive. That's not going to work. Here, if you're going this way, you'd have a, is this negative or positive down here?
Negative.
Negative over, is this negative or positive? Positive. So negative over positive is a negative. That means cotan's negative. Is that good?
Yes.
So what quadrant?
2.
There's your final Boom. Okay. Now, ooh, we're doing great on time. Well, I think. Seems like it. Let me see. We're doing not too bad on time. Okay, these last ones are a doozy. I might as well say this. There's a mnemonic device. It's in your book for the quadrants.
Oh, it was like smart.
A smart trig class. And so this is all, sine, tan, cosine. And the question is, which is positive here? Here, they're all positive. Here, sine is positive. And if sine's positive, what's also positive?
Cosecant.
Cosecant. Cosecant is positive. Here, tan is positive because you have a negative over a negative, right? We talked about that, right? So if you're doing this,
That'll be helpful.
opposite over adjacent, right? So negative number over negative number is a positive number, meaning tan's positive, which is also what's positive? If tan's positive, cotan must be positive. Now here, cosine is positive because, well, the x value is positive. And so if cosine's positive, what else is positive? So, and it goes without saying. So again, that's a smart trig class. That, so this is for which ones are positive. And if it says that cosine's positive, you know cosecant must be positive. And the implication is all the others are negative. Okay? So that's the case. Everybody else is negative in those. Okay, so there's that. Although, I mean, it's a nice mnemonic. I would encourage you, though, to really start thinking about these in terms of, well, I know that this way, the x values are the cosine values. This way are the sine values. And so, okay, we have number 86. It says, find values of, can you guess the values of the 6 trig functions for the given conditions? 86. It says that cotangent theta equals 3/4 and, okay, cosine theta
We already have 2 of them.
is negative.
So
wait a second. Cosine's negative. Where does that occur?
the left two.
The left two. I like that. That's how I like to think about it. It's over here somewhere, right? Because cosine corresponds to the x values, and so it's over here somewhere. And then we have two possibilities. Either this thing's sticking out here, or this thing's sticking out down here.
Oh,
And so cotan
is positive.
is positive. So what must it be?
The third one.
It has to be down here. It has to be the case that it's down here. Otherwise, you'd have a negative in there somewhere, wouldn't you? Because if it were here, you would have, well, cotan would be adjacent over opposite. You'd have one would be negative, this one would be positive, and so that would be negative, so it can't be that. Has to be the case that we're down here. Now I'm just going to go ahead and draw it like 45 degrees. Meaning, all right, now let's get these sides. Which one's which?
Adjacent is 3. Right?
Which one's adjacent?
Oh, the one on the axis.
This one is the adjacent, and you say it's 3. I think I agree. Meaning that that's what?
4.
That's 4. Now let's just think about this. Cotan is what over what? In terms of opposites, adjacents, and blah, blah, blah.
Adjacent, opposite, no, adjacent.
Adjacent over opposite. And so cotan adjacent over opposite. Cotan adjacent over opposite. Yes, 3 over 4. Okay, cool. I buy it.
So if you find that button.
And so, again, one more thing though. Remember that the actual angle we're measuring is all the way to there, but we're going to use that in the following way. So let's do this. Sine cosine, tan. I'm not going to bother with the others. Okay, so what's sine theta?
Well, we need to find that.
We do! Okay, and what is it?
No, root 4. Wait, root 25, which is 5.
Oh,
There you go. Yes.
Oh.
That's one of those easy ones. 3, 4, 5. It does work out to be yes, because it's 16 plus 9 is 25. Square root of 25 is 5. So there you go. Okay, so what is sine?
4 over 5. Uh, 3 over 5. Oh, negative. Oh, negative.
Careful. Careful. Because yes, if we were just talking about that triangle floating out by itself, from now on, you'd better be very careful of what you're doing and then start to think about signs. Ugh, pluses and minuses. So annoying. Okay. Okay, now what about cosine?
Negative 3 over 5.
There you go. Negative 3 over 5. And then tangent must be.
Positive 4 over 3.
Now, there's a couple ways of seeing that, right? Like, on one hand, tangent is sine over cosine, so you have minus 4/5 over minus 3/5, which is minus 4/5 times minus 5/3. Those cancel, the negatives cancel, and we have 4/3, or also that one over that one. That's a negative, negative is positive, etc. I'm not going to bother with the others.
And we already know what cotangent was.
That's a great way of testing. And actually, I think I did write that down. This is a great way. So on one hand, you know that your cotan should be, just looking right there, it should be 3/4. Because, right? And so there's two ways of checking now. Okay, so that's what it should be. Does that agree with this? Does that agree with this?
Yeah.
Yeah. It does, right? Because cotan, okay, is adjacent over opposite, -3, -4. So it is positive. If you guys want to go ahead and do this as well, that's perfectly fine. As you're learning this stuff, include the sign with your lengths. That's cool too. Like it's not how I do it. There may have been a time where I did. I don't know, but that seems like it might be helpful as you're doing this. As you construct your triangle, you just say, "Wait a second, hold up. Is this a negative length? Yeah, it's negative because it's over there. So that's that. Is this below the x-axis? Yes. Oh, so it's negative. Maybe that'll help. Maybe not. Might make your life miserable. I don't know. So okay, we have time. Let's do another one. Ooh, that's kind of brutal. All right, let's do same thing. It's not bad at all. But 90 cosecant theta equals 5. And whoa, wait. Oh yes, because that's possible. Okay, never mind. And cotan theta is negative. So what quadrant are we in? Let's think about there's an easy one to do first.
So it has to be one of the top two.
It has to be in the top two because cosecant is the reciprocal of sine. And so if that's positive, sine's positive. Sine's only positive in the top two quadrants. And so we're up here somewhere. Now, cotan's negative.
Well, it can't be the first one then.
Can't be the first one. Everybody's positive over here. So it has to be this one. So we're doing something like this. But now, okay. Now what?
Well, cosecant equals
Is
5
over
so
1.
It's 5 over 1.
Okay, I like that. Cosecant theta is 5 over 1. And so that corresponds to which sides of this triangle?
Hypotenuse over opposite, so it's the hypotenuse is 5.
Okay, the hypotenuse
Should
is
be 1,
5. And which one of those is 1?
The opposite, which is the
Opposite.
up one.
The up one there, I like that. I like that. So there's theta
It should
sub
be-
r right there. And so what would that be?
1 squared.
It'd be
Root
root
24.
24.
I think so, because it would be 1 squared plus my thing is equal to 25. My thing is going to be 24. That's my thing squared. And so, yeah, root 24. Root 24. Okay, so let's do them. So now, in order to check stuff, I mean, we could just look, we could just blindly say, well, if cosecant's that, it should be 1 over 5. Let's make sure we've done the right picture. What is sine according to the picture?
1 over 5, which is
Which is what we expect. Okay, so that's nice. I'm using that to make sure that I've set everything up the right way. Now, what about cosine?
Root 24.
root 24 over 5. Negative.
Negative.
Negative root 24 over 5. Good. Make sure you catch yourself with that. Good job. So, now tan is what?
Negative root 24.
Positive. No, negative.
No, negative 1 over root 24.
Yeah, 1 over root 24, one of them is negative, which makes the whole thing negative. Yes. And so then we could get all the others by just flipping each one of these guys. And I think that's it.